Okay, hi everyone. So today we will be going into lesson 5 under the topic of algebra. So if you are referring to your textbook, same thing, go to chapter 7 further algebra. So for today's learning outcome, we will be focusing on only one thing, which is we will learn how to use the expansion of 1 plus x to the power of n, where n is a rational number and the modulus of x is lesser than 1. So I hope that when we go through this learning outcome here, you can actually already identify this is something that you have learned previously in P1, which is called as binomial expansion. But last time when we learned this expansion, right, we only deal with all the indices that is positive integer, meaning like to the power of 1, 2, 3, 4, 5, and so on. But today we are looking at all case, meaning like all the rational number, as long as it's not an imaginary number. So what are we trying to learn today is two things. The first one is how do we actually expand 1 plus x to the power of n when your n is no more a positive integer. So in another words, it will be like -1, -2, -3, all the negative integers or even fraction like 1/2, 1/3, and so on. Okay, so then after that, from the first formula that we have, we'll try to apply it in the case if we have like a plus x, meaning that our first term here is not 1. So we'll be looking at these two scenarios today. Okay, so when you look at the learning outcome, you can realize that like how do you generate the general term is not included, meaning that you do not really need to know how do you prove the formula itself, but the idea is how do you use the standard formula to help you to solve the equation. And you also need to know how to determine the set of value for the expression is valid or not. Okay, so don't worry, we'll try to look at it one by one. Yeah, so as the introduction, right, so same thing like all the lesson, I'll try to explain to you like how the formulas come from. But as what I have mentioned just now, so this is not really included in your syllabus itself. It's just for your exposure and understanding. So if after you write down the notes, you feel like you don't understand and so on, it's totally fine. So what is important is the application later. Okay, so I'm going to go through this part like very quickly so we can like spend more time in the question itself. Okay, so let's do some recap. What you have learned previously for P1 is like a plus b to the power of n, right? So when you expand it, you will be able to get a to the power of n plus nc1 a n minus 1 b1 plus nc2 a n minus 2 b2 plus nc3 a n minus 3b3, and it will continue up to bn. Okay, this is what we have learned previously. So same thing, can we try to do from a plus bn? Let's try to change it to 1 plus x because that is what we want today. Okay, so same thing, you are just substituting your a to 1 and b to x, right? So 1n plus nc1 1 n minus 1 x power of 1 nc2 1 n minus 2 x square plus nc3 1 n minus 3, then x3 plus until your b now is x. Okay, so let's try to simplify it. So you can see that 1 to the power of n, 1 to the power of n minus 1, 1 to the power of n minus 2. So all this term will give you the same answer, which is 1. Because 1 to any indices, you are still getting 1, right? So let's try to simplify it. So nc1 x, nc2 x squared, and C3, you have x cubed, and so on until the last term is xn. Okay, so now you can see If let's say I were to substitute a positive integer here, then the whole thing makes sense, right? Because I'm just going to substitute n, then I'll be able to get my expansion already. But what if my n is a fraction number or even is negative? So if you are using your knowledge, like when we talk about combination, right, then you know that it's not logical if we try to say that from a negative number you want to pick something, or like from 1 over 2 you want to choose something. So when your n is fractional or integer, if we talk about the definition for NCR, right, we know that the formula for NCR is actually n factorial divided by n minus r factorial and r factorial, right? So since our n is a negative number or a fractional number, how can you expect yourself to substitute your n here? Because if you want to continue, then your factorial should be up to 1, right? When we talk about 3 factorial, we means 3 times 2 times 1. But if let's say your n here is negative 5, then how am I going to do that? Because when I continue to minus 1, minus 1, minus 1, I wouldn't be able to get 1 at all, right? So this thing will become meaningless already, right? So it's not, or has no meaning, yeah. Okay, so what we will try to do here is we will try to, from the formula itself, instead of using NCR, can we try to further simplify this? Okay, so let's try to look at that. So if we have NCR equals to n factorial divided by n minus r factorial, Okay, so let's try to imagine what is n. N is basically n times n minus 1 times x minus 2, and you will continue, right? Then in the middle, maybe we'll go through the part where, because you have your r here, we can go through the part where we have like n minus r plus 1, n minus r, and then n minus r minus 1. Then after that, you get to like 3, 2, 1, right? So this is basically what will happen when we talk about combination. Sorry, when we talk about factorial. So same thing, if we have n minus r, that meaning it will be n minus r, and then n minus r minus 1, n minus r minus 2, then you will continue, right? Then after that, your r factorial is basically r, then, sorry, your 3, 2, 1 as well. Then after that, for your r factorial, we are not trying to simplify here because you don't have anything that you can simplify with. So it's all right. Okay. So up to this point, then what you can realize is I can try to cut off something already. So you can see n minus r plus 1, n minus r here, cancel out, n minus r here, cancel out. Then after that, n minus r minus 1 also cancel out. Then you can imagine the whole thing here will be the exactly same number, right? So the whole thing here will be cancelled out. Correct? So what do you left? You left with this part and this part. So you left with n minus 1, n minus 2, okay? And the whole thing, and then n minus r plus 1, the whole thing divided by r factorial. Okay, so it looks like very complicated here, but let's try to put some number inside. Okay, let's say if you are having NC1, how is that going to look like? Okay, so if you change it to NC1, meaning that your R now is 1, right? So this is r factorial. We will continue this series until n minus r plus 1. So you can imagine if I were to substitute a 1 here, then I get negative 1 plus 1, which what do I left? I left with n. So from n to n, what do you have? You only have n. You get what I mean? because this thing only can continue if this number is like x minus 5, then you need to do n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. But now your r is 1, right? So that's why when you substitute 1 here, you get only n. So meaning n continue up to n, you only have n. Then after that, your r is 1 factorial. Then after that, when we look at NC2, then what happened? So meaning that you will need 2 here. So negative 2 plus 1, you are getting n minus 1. So meaning the sequence is n and n minus 1. So meaning n minus 1, and 2 factorial. So same thing if we go to NC3, then what will it be? So if you substitute your 3 here, then you will be able to get n minus 1. So your series up there will become n times n minus 1 times x minus 2. Then r factorial will become 3 factorial. So I hope that you can see the pattern now. So it's basically like NC1. So n divided by 1 factorial. So NC2 meaning you will repeat 2 and then n minus 1, then 2 factorial. NC3, then you repeat 1, 2, 3, then divide by 3 factorial. Okay, so this general term can be used in anything for a combination, no matter what is your n. So meaning that if it's a negative, you also can substitute here because now you are not looking at factorial anymore. It's just an n here. Okay, so let's try to put it inside our formula that we have gotten just now, which is this one. Okay, so let me just try to copy first. Okay, 1 plus x n equals to 1 plus nc1x plus nc2x squared plus nc3x cubed plus until xn. Okay, so now since we have gotten this right, so let's try to substitute. So 1 plus n divided by 1 factorial. I mean, of course, you know that n divided by 1 factorial, you get n lah, yeah. But I'm just writing this down like this so you can see the pattern, yeah. So x plus n minus 1, 2 factorial x squared. This is what we have got. So now nc3, this one. So n minus 1, n minus 2, and 3 factorial. Okay, so now what you can realize here is how can we continue for the xn? So the question here is, will you reach the xn that you want? So you see, now you can imagine that, I mean, of course, this formula can be used for your general binomial expansion, but we don't do that much because like you only can solve like 1 plus x. So, I mean, it's meaningless if you want to use this, yeah, because normally you have something that is much more complicated than this, but our focus today is for the n that is a fraction and is negative, right? So you can try to imagine as you continue this series, right, you wouldn't be able to reach a finite n. So you imagine that here is x0, then x squared, and x cubed. Sorry, I forgot. X cubed, and so on, right? So you are continue with x power 4, x power 5, and so on. Imagine that your n here is a fraction or a negative integer. It will not be up to a point that you can get that number. So that's why for this series, it's an infinite series. So you do not have like binomial expansion, which you have your last term. It's going to be like a infinite, like a infinity series. Okay, but then there is some constraint about this formula is that when we try to use this, right, the first thing is always infinity, is an infinite series. So because it's an infinite series, what we have learned previously in GP, when we talk about your ratio, your common ratio must be lesser than 1 so that the series goes convergent. So it's the same thing for this series. So the second thing is this series only valid when your x here is lesser than 1. because what you can see from this series is like not looking at the constant part. The x part is like everything times x times x times x and so on. So meaning that we are looking as if a case that is like a common ratio. So only if your common ratio, the modulus is lesser than 1, then you can have a convergent series and you can find your binomial expansion. Because if not, then if this is a divergent series, right, you are getting a number that's like larger and larger, so you cannot really find, because once you add up the next term, it's going to make big changes to the previous number. So that's why you cannot find an exact number. But if it's a convergent series, as we continue, the number gets smaller and smaller. So that's why by finding like few terms in front is more than enough for us to get the answer for this expansion. Okay, so don't worry if you cannot understand this part. So what is important is you know how to use this formula. So now we are looking at the part which we talk about the formula. Okay, so look at your second page. So this is the general binomial theorem. So it can be used for any rational value of n. So meaning like any number of n, not even is positive. But as I said, this only applicable for 1 plus x. So meaning that you have something that is much more complicated than this when you solve in your P1. So I mean, you wouldn't want to use this formula. Okay, so your n is rational and your modulus x must be lesser than 1. So noted that the series is infinite, so meaning that you do not have your last term. And then the expansion is only valid for modulus x smaller than 1. So as what I have explained just now, same thing, it must be a convergent series. Then by doing that, you have a sum of infinity. So that's why only you can try to do this expansion. All right, so now we'll be looking at some questions. So you can see that in your notes, there's the second part. So I'm going to go through the example 1 to 4 with you first. Then after you get used to the formula, then only we move on for the second part for the notes. Okay, so same thing in your notes itself, I also put in like the formula. So this is the formula that will be given in your exam. So they will write like binomial series. Then after that, this part is basically the part that you have learned in P1, which your n is a positive integer. Then they give you the formula for combination. Then after that, the third line will be the formula that we are going to use today. Okay, so let's look at example 1. So don't worry lah, it's basically just about formula. Okay, so expand the given binomial expansion in ascending powers of x up to and including the term is in x cubed. Then state the range of values of x for which the expansion is valid. Okay, so the first thing, let's try to do the expansion first. Okay, so what you do is just follow the formula. 1 minus 3x to the power of negative 2. Okay, so now your 1 is still 1, but your x is negative 3x. So what you try to do is just change all the x here into like negative 3x. Okay, so 1 plus, okay, then what's your n? So your n is negative 2, right? So negative 2, your x will be negative 3x. Okay, don't forget when we talk about x, meaning the whole thing here, meaning the whole b here. Okay, then after that, plus the next term. So your x is negative 2, right? So it will be negative 2, then negative 2 minus 1. So your next number, negative 3. Then after that, divide by the second one is 2 factorial. Okay, then after that, x squared. So which means negative 3x squared plus same thing. Now you have your n negative 2, negative 2 minus 1, negative 3. Then after that, negative 2 minus 2, negative 4. Then after that, 3 times, so 3 factorial. Then after that, your b, meaning your x, then power of 3. So it's enough lah, because this question only 1 up to term 3. Okay, so actually the easier way to do is sometimes for this part, right, I will just write it as the way like divide by 1 factorial. So you can remember for the first one, you just copy the first term, Then after that, you remember all the power, how many times you write, then you write how many factorial below. So meaning that you see -1, then divide by 1 factorial, -2, then -1, -3, then become 2 factorial, like 2 times you write. Then after that, -2, -3, -4, so divide by 3 factorial. Then after that, you are going to always times your x, and then what is the power that you are going to write is the exact number as your factorial. So like 1 factorial, then this is power 1. Then after that, 2 factorial, so this is power 2. 3 factorial, so this is power 3. So you can do not need to like keep on referring to the formula. Yeah, okay, it's all right. It's your first time. Then after that, when you try to do it like more frequently, then you will get the idea. Okay, so same thing. Then you will just use your calculation and so on to get the answer. So 1 plus 6x and then plus 1, 2, 3, 4, 9 6 divided by 2, 3, 3. So you get 27 x squared plus the next one divide, so 0, yeah, 108 x cubed plus and so on. Okay, just like that. So what is important is you must please make sure that in your exam the first step is very important. So please write down, please do not skip your answer, because you need to tell the examiner like how do you actually get the answer. So write down the formula and the substitution is very important. Okay, so you finish the first step already, which means you expand it. Then after that, state the range for the values of x. So you remember, for all the expansion to be valid, your x part here must be lesser than 1. So -3x must be lesser than 1. Okay, so you continue to solve this. So you get 3x lesser than 1, and then your x will be lesser than 1 over 3. Yeah. So you can see some of your textbook, they actually only leave the answer up to here, but some of the textbook will try to solve this as well. So I mean, depends on what's the question one, then you answer lah. But if you want your answer to be more complete, then I will say this is the much more complete answer. Okay, so meaning this expansion only valid, yeah, this expansion is valid for -1 over 3 until 1 over 3. Okay, so this will be the answer for number 1. Okay, so let's move on to number 2. Okay, so expand 1 plus 2x squared, expand 1 plus x squared to the power of -3 in the ascending power up to and including the term of x6, then simplify it. Okay, so same thing, what you need to do is use the formula itself. Okay, so let's try to do it like without substituting one by one. So you just think it in such a way that how we did just now, x squared then -1. Okay, so started with writing your first number, which is 1, and then plus. So you know that the next one is going to be your n, right? So -3, since you write once, so 1 factorial times with your x, which is your x squared. This is power 1 also. Okay, same thing, plus. Then after that, your n, you write your next n, then 2 times, so 2 factorial. So this also 2. Okay, so the same thing, but now 3 number, -3, -4, -5. So that's why you write 3 factorial. Okay, then after that, x squared also power 3. So now you realize that here you already get x to the power of 6, right? So they only want up to x power 6, so that's why I no need to continue anymore. Okay, easy, right? Then after that, you can continue 1, then -3x squared plus 12, so 6x4 minus 10 x6 plus so on. Okay, so this will be your answer. So you can realize that in this type of question, right, normally it's either like the whole thing positive, meaning add, or like minus, 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 or you will have alternative, you will have like alternate sign, like negative, positive, negative, positive, negative, positive, and so on. So it's the same thing like when you have like geometric series like that. Yeah, because when we look at this, then it's actually your common factor here will be caused by the x. I mean, of course, there's a constant there lah. Okay. So same thing, state the range of the x. So meaning your this part should be lesser than 1, right? So we can, yeah, no need to repeat the sentence later. So expansion is valid when modulus x squared is lesser than 1. So when you continue to solve it, then meaning modulus x lesser than 1. So -1 until 1. Okay, so this will be your answer for number 2. Okay, so now let's move on to number 3. Find the first four terms in the expansion of 1 plus 2x squared to the power of 4. State the range of the, so they are just asking the same thing lah. Yeah, so I put in the example, so just like for you to really understand how it works. Okay, so same thing, 1 plus 2x squared minus 4. Okay, so until here, so 1 and 2 I already show you the steps. So the same thing, like depends on you whether you want to use like the formula and then substitute one by one, or you can just understand how the whole pattern works, then after that just follow. Okay, so your first number, okay, then after that continue with your n. So since you write only one time, so 1 factorial, your next term will be power 1 as well. After that, next term, so same thing. Then after that, you have your -4. Next term, -5. So that's why 2 factorial. Then after that, 2x squared will need to square. Okay, then plus, same thing, -4, -5, and -6. So when you write 3 terms, so that's why you have 3 factorial and then 2x squared to the power of 3. So the question only one first 4 terms, so this will it be. Okay, so after that, let's try to get your answer. Get 1 minus 8x squared, 20, so 10, and you get 40 x power 4 minus 3, so you have 4, 5, 20, 120 divided by 6, 2, so 160 x power of 6. Okay, plus so on. Alright, so this will be your answer. Yeah, so you can see this is like a alternate sign as well. So same thing, expansion is valid when, what's your b term, is 2x squared, right? Okay, lesser than 1. So same thing, just try to what's that called, solve it. So you will have x lesser than, put 1 over square root 2. Okay, you should know how to do this lah. Square 1, then x equals to 1 over 2, then the whole thing, right? So 1, so 1 over 1 over 2. Okay, so you will have -1 over square root 2 up to positive 1 over square root 2. Okay, so this will be your answer for number 3. So I just want to speak about this. Is like you should aware of this, like for your number 1, or yeah, for your, especially the example in your number 1. So make sure that if this is negative, when you write, when you put in your x part, right, so make sure that you have a negative as well, because it's going to change your sign here. Okay, so make sure that if this is positive, then of course it's going to be positive lah. If this is minus, then make sure that you write negative as well. Okay, so let's move on to next questions. Okay, so move on to number 4. Find the coefficient of x cubed in the expansion of x minus 5 over 1 plus 2x. Okay, so this is much more complicated compared to the previous questions now. Okay, so but it's the same thing. So what do we try to do is, let's try to change it into index form first, so we know how to do next. So you have x minus 5 divided by 1 plus 2x. Okay, so how do we write it in x form? So you'll be changing it to x minus 5 multiply with 1 plus 2x. power of -1, right? Okay, so now which is the part that you need to do your binomial expansion? This part. So you can try to ignore the x minus 5 first. Or if you want to put it together, can also, yeah, I mean, that's no problem. Okay, so if you want to continue to do that, then, no, I think we do it separately lah for the first time, okay? 1 plus 2x, let's try to expand this first. So what can you get? So you have first term, and then plus, then after that, power, 1 factorial, 2x power 1 plus same thing power next power 2 factorial your x power 2 plus power minus 1 power minus 2 divide by 3 times, so 2x 3. Okay, so since this question want to find x cubed, then you know that when you continue to write, then it will be more than x cubed already, so you do not need to do that. So 1 minus 2x plus 4x squared minus 8x cubed, and so on. Okay, so now after you get this, then you can continue with your equation here. So we have x minus 5 1 plus 2x power -1. So x minus 5, then we can substitute the expansion that we have found here. 1 minus 2x plus 4x squared minus 8x cubed, and so on. Okay, so now you can find your coefficient. So you can, like, it depends on you whether you want to expand it or not. So or it will be easier for you if you can check it like this. So you know that if you try to expand, then you will try to use x to times everything here, right? So you can just write x, then you times the whole thing in the expansion itself. Then after that, you will do the same thing for the second part also. So it's like minus 5, then you will multiply the whole thing. So from here, you can get what you want lah. So this question want the term for x cubed, right? So coefficient of x cubed equals to, then what you have here. So x, for you to get x cubed, then you need to times here, right? So that's why 1 multiplied by 4. So for the 5 here, if you want to get x cubed, then you need to times with the 8 here. So meaning -5. And after that, you need to times -8. So this is how you get 4 plus 40, which gives you 44. Okay, so it's the same thing if you want to write x cubed. First, you find the x cubed, then after that, you write down your coefficient lah. So it's the same thing as well. Alright, so that's the question for number 4. Okay, so now we'll be continue for the part where we talk about a plus x now. So you can look at your notes part. So for the second part, we are looking at the expansion where is a plus x to the power of n. So just now, when we talk about the formula, we use like 1 plus x, right? So how if my a is not 1? So we will be able to use this, okay? So same thing, that is a formula actually given in your textbook, but what I try to do is I will not go to that approach, because in your exam, it will not be given for you the formula as well. So in your exam, they will only give you the formula that we did just now, which is this one. So that's why it's important for you to know how to do the first step. Then after that, you continue with this one without memorize the formula itself. Okay, and because it's very easy, so that's why just try to understand it. Okay, so to expand a plus x to the power of n, where n is not a positive integer, we take a outside of the bracket. So meaning that if you know that one of the law in your indices, right, is something like a times n times bn. If they have the same indices, you can actually combine them into 1 and n. Okay, but the idea now is our b is like the whole thing here. So what you will need to do is when you take out your a, you must make sure that you have n also. So meaning that, for example, when I try to do ab to the power of n, okay, so when I take out my a, I cannot only write like this. So because the indices for n here also belongs to a, right? So that's why when you try to take out the n also need to follow the a. So it's the same thing if I want to factorize and take out the a. So meaning my a here will become 1. Then after that, my x here will become x divided by a. Then when I take out my a, I must make sure that my n is taken out also. Okay, so just by doing this, then we can solve the question. Okay, so before we move into like the real question, I put in like 3 example here. So I just want you to I just want you to write them into the form that we have learned just now. Okay, so you see your a now is 5, right? So we need to change the a here into 1. So what's the number that you will need to take it out? Is 5, correct? Then after that, what do you left in the bracket? 1 minus x over 5. Okay, so now don't forget you still have your power. So remember the a that you have taken out must have the power as well. Okay, just simple as that. So you just think of it as a way that you do your factorize. Then when you write your power, don't forget your a also need the power. Okay, so just like that. So after that, you can continue. So 5 to the power of -3, you get 1 over 125. And then 1 minus x over 5 power x cubed. Okay, so this is the part that you can now continue with your binomial expansion by using the formula just now already. Okay, so same thing for number 2. So let's try to change it in indices. 2 minus 6x to the power of 1 over 2. So same thing, the number that we need to take out is 2 because I want to let the 2 here become 1, right? So I do the factorize. So 2, then I get 1 minus 3x, correct? So as I write the indices here, then I don't forget the indices in front. So I will have square root 2 and then times with 1 minus 3x 1 over 2. So I'll be able to do the whole expansion here. Then after that, I times square root 2 for each of the term. Same thing, the last one. So try to change it into index form. 32, 4 plus 2x negative 2. Okay, so same thing, I do the factorization. So for the 4 here, it's okay. So don't confuse yourself. So you just write the 32. No need to bother about it anymore. So you open a big bracket. So 4 and 2. So the 4 needs to become 1. So that's why factorize 1. Then after that, you left with 1 plus 1 over 2. Right? So after that, you will continue with your x. Okay? Then your power. And don't forget your power in front also. Okay? Do I do it? Oh, sorry, 4. Yeah, factorize, I take out 4, then left with 1. Yeah. So after that, now you only times them together. So 4 to the power of -2, you are getting 1 over 16. So that's why 2. Then 1 plus 1 over 2 x, oops, x -2. So this is the part that you need to do binomial expansion. Then after that, you only multiply with 2. Okay, so let's try to look at our last 2 example. Okay, example 5. So expand 2 plus x to the power of -3 in ascending power of x up to and including the term in x power 3. State the range of value which the expansion is valid. Okay, same thing, but now we are looking at the the expansion that you have your a is not 1. Okay, so follow the steps that we have learned just now. So let's try to do the expansion. Okay, so to let the 2 here become 1, so you need to take out 2, correct? So take out 2, do your factorization. So 1 plus x over 2. So when you write the power, don't forget the power for your 2 as well. Okay, so now for this step, then now you can try to continue like normal already lah. So equals to 1 over, so 2 power of 3, you should get 8. Then you can try to do your expansion now. So I'm just going to write it first because I scared that I do not have space here. But you can always start here already. Okay. So equal to, you should write here because I don't have enough space. Okay, 1 over 8. So the same thing, you just expand it. So 1 plus your power first time, and then x over 2 power 1 as well. Then after that plus, oops, okay, plus, same thing, your power minus 1, 2 factorial, x power 2 plus negative 3, negative 4, negative 5. So that's why 3 factorial x over 2 power 3. Okay, up to x3. So this is enough already. Then you can continue. 1 over 8. Same thing, get your answer. 1 minus 1 over 8 x plus, oops, I'm sorry. No, is 3 over 2x. Okay, plus 12, 2, 4. So you have 3 over 2x squared minus 5 over 1, 2, 3, 8, 20. Yeah, so divide by 4 x cubed plus so on. Okay, 12, 66, 10 over 8, 5. Yeah, correct. Okay, so you can continue by multiply them together. So 1 over 8 minus 3 over 16x plus 3 over 16x squared minus 5 over 32x cubed and so on. Okay, so same thing lah. So after you finish whole thing, if you want to check something, then you just make sure that you cannot have the sign like negative, negative, positive, then you know that something must be wrong already. So it must be like alternate or like the whole series, they have the same, what is that called, same sign. All right. Okay, so let's look at our last example. Okay, I forgot the second part, which the expansion is valid. So same thing. So please try to make sure that when you try to do this type of question, your expansion is valid for the modulus x, right? The x is not referring to your original equation. So if, because, although it's like a plus x, but you are using the formula of 1 plus x as well. So please make sure that it's valid when your modulus x over 2 is lesser than 1. Okay, so meaning you should take the x when you have written in 1 plus x. So you are not getting your x, which is for your original equation. Okay, so after you have gotten this, then it should be square root, no square root. So negative 2 x up to 2. Okay, so this will be number 5. So now only we go to number 6. Okay, number 6, expand 1 over square root 4 plus x in ascending power, blah, blah, blah. Same thing up to term x squared. Then after that, find the coefficient of x squared in the expansion and so on. Okay, so this question, same thing. They want us to expand it, then after that, find the coefficient. But this is going to be a little bit tricky because you see there's a square root here, meaning that you are looking at a fractional indices now. Okay, so let's try to expand it. Don't worry, you just try to do it like normal lah. So tricky, just in the form of like your calculation, you have fraction, that's it. Okay, so 1 over square root 4 plus x, same thing, try to change it into indices. So you have 4 plus x to the power of negative 1 over 2. So you can realize that your a is not 1 again, so we need to do the factorization. So take out 4, 1 plus x divided by 4. So when you write your power, don't forget your power. Okay, so same thing. So square root 4 and 1 over, you will get 1 over 2. So 1 plus x over 4 power negative 1 over 2. So now we can start with our expansion. Okay, so same thing, you should continue here. So 1 over 2, and then when you expand, 1 plus, okay, so your power is a negative number now. So just treat it like a normal number. So yeah, don't be worry about the fraction. Okay, same thing, 1 factorial. Then after that, x over 4 to the power of 1 as well. Yeah, I mean, if you can remember the formula well and you do not want to use this method, you can just ignore me like the 1 factorial and 1 way to write. You just write n and then your x. Okay, and then plus, same thing, your power, and power minus 1, you have negative 3 over 2. Okay, divide by 2 factorial, then x minus x divided by 4 square. Okay, so the next one, you will have negative 1 over 2, negative 3 over 2, and negative 5 over 2. Oh, okay, this question only want x square. Actually, up to here is enough already, but yeah, if you have written, then you just write out, is fine. Okay, so x over 4, 3, then you, okay, alright, just delete this. Okay, yeah, just up to x square, so this is more than enough. Alright, then now you can just get your answer, 1 over 2. So what you will get here is 1 plus negative 1 over 2, so you should get a negative, and negative 1 over 8. Yes, okay, x plus 3 over 16, 4, 4, 4, 8, 1, 2, 8, x square, okay, plus etc. Alright, so now let's multiply your 1 over 2 inside. So 1 over 2 minus 1 over 16x plus 3 over 256 x square, and so on. Okay, so now use this to find the coefficient of x square. So, oh, don't forget your expansion, the thing. Okay, expansion is valid for your x is x, right? So it's just x lah. Sorry, yeah, don't forget this. So you should be looking at this, not this. Okay, the 1 plus that one. So valid for x divided by 4 lesser than 1. So that's why it will be x lesser than 4. So negative 4 up to 4. I think I forgot to do this for the previous question. Later, let's try to add it. Okay, after that, what is that? Yeah, so you need to continue to find the coefficient for x square, which 1 minus x square at 3x, 4 plus x. Is that your questions? Yeah, okay, 1 minus 3x divided by square root 4 plus x. So same thing, just try to write it. 1 minus 3x, and then 4 plus x, negative 1 over 2. Okay, so this is exactly what you have found just now. So you just copy down the equation. So 1 minus 3x, then you have 1 over 2 minus 1 over 16x plus 3 over 256 x squared plus so on. Okay, so same thing, if you want to make yourself like much more clearer, you can just try to state the whole thing again. So 1 times 1 over 2 minus 16x plus 3 over 256 x square, so on, and then minus 3x, copy the whole thing again. Okay, so the question 1, the coefficient for x square. So for you to get the x square, you need 1 multiplied by x square here, right? So 1 multiplied by 3 over 256 minus 3, x need to times x. So that's why negative 1 over 16. Okay, so you'll be able to get 3 over 256 plus 3 over 16, which will give you 51 over 256. Okay, all right, so that's it for today's lesson. So for Friday's lesson, we will try to finish up this topic already. So please try to do your exercise. All right, thank you.